Welcome to ITKM 560, Classification and Regression Trees. So, classification and regression trees is an algorithm that will predict either a dependent classification variable or a dependent variable that is continuous at regression. So think about this. It can do either one, but you should specify it. And to specify it, we'll see how to specify it and also how to prepare your data so it will classify and not treat it as a regression tree. So let's load up our libraries. And again, if you don't see this library in your packages, okay, then you need to install it using this syntax. Remember, this is commented it. To uncomment, I just take out this, commented back. There we go. So let's load up. So we're going to use our part, tidyverse, readr, although it's part of tidyverse, rpart.plot, and gmodels. So let's use our dataset, the affairs dataset. And the first thing I'm going to do is that I'm going to create the variable cheater. And we've done this in prior classes where basically if you have more than one affair or more than 0 affairs, we are classifying you as a cheater with the number 1. And if not, if you're not a cheater, a 0. There's an additional step. As you see, I wrap the whole if-else statement with as factor. This is very important because with as factor, we're telling R that the variable cheater is not necessarily a number, or if it were a character, yes and no, it's not necessarily a character, it's a factor, meaning that there's levels to it, okay? This has just 2 levels, 0 and 1, but it has levels. So, and I'm also creating the random variable so we can split our data set into training and validation. And I am taking away the variable affairs, because we're not going to be using affairs to predict, because obviously if you've had more than one affair, then you're a cheater. So we're not going to be using that. So I create my data set cheater, okay? I can do a little summary here. And as you see, because it's a factor, you see, I did my summary not on the entire data set, but just on cheater, okay? And on the variable cheater, data set cheater, variable cheater. And here we can see it says 451 and 150. Now, however, if we do the summary on the entire data set, okay, we're going to find something interesting. We have occupation, and we know that occupation over here is a category. So let's say that it's a category. Let's tell it it's a category. So we're going to do that as well, just to be consistent and not to be sloppy, okay? Because if not, it's just treating it as a number. So we're going to do as factor occupation, occupation. And we also have other categories. Sorry, let me just do this. And I'm doing this on the fly here because I want to show all of you how you can just copy and paste and just do some slight modifications just to satisfy things. So we also need to have children and gender as factors. So let's do that. So I'm going to do children and gender. Okay, so let's run this again. I have my dataset cheater, and let's run this again. So as you see before, when gender, I just said it's a character, blah, 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 length, blah, blah. And same thing with children. But now, because we made them factors, I'm going to run this code. And look what we have. We have a count of how many female and males, children. That's what a factor does to when you're using the summary statement. Okay, so creating my training data set, my validation data set, and let's create our first tree. So to create our first tree, we're going to use the function rpart. We're predicting cheater. We're dumping all the other variables as predictors. I'm using the dataset train and method equal class because it's a classification. Run this. I all inserted it all into an object called CT1. Now for the good part. I want to expand my screen here for this, because this is where it's going to show up. Wherever you have this, I have my windows different. So here we can see this better. I can do a little zoom. Okay, I can see it here. But I want to show you guys this. If I were to expand this even more, the quality of the image, this is one of the little quirkinesses of R. Okay, I rerun this. My image is a little bit better. It just boldened a little bit. Okay, this is a decision tree. So let's talk about how we're going to interpret this decision tree. Okay, we're going to interpret this as follows. We have 3 statistics here, and we have a decision. The first statistic is that what is the prediction over here? The prediction is 0. You're not a cheater. What proportion of the data is a cheater? 26% of the data is cheaters. What proportion of the total data are we using? We're using 100% of the data. So in other words, if I know nothing about a subject, I will predict that they're not a cheater. Why? Because 26% of the people in the data set are cheaters, while 74% are not cheaters. So my best guess is that you're not a cheater, this little 0 that we have here. And again, we're using 100% of the data. Then the decision tree starts splitting. So to the left is a yes, to the right is a no. What's the decision? Is rating greater than or equal to 3? If it's yes, we go down here. If it's no, we go down this path. So if you rate your marriage with a 3 or greater, this is predicting that a 0, that you're not a cheater. What proportion of the people that rate their marriage with greater than or equal to 3, what proportion of them are cheaters? 22%. What proportion of the data was used here? 85% of the data. That means 85% of the subjects in this training data set rate their marriage with a 3 or more. And that's how we read the decision tree. Now, I'm going to interpret this long way down over here, okay? Actually, just for time's sake, I'm going to interpret this one over here with 2 decisions. So I'm going to interpret this right over here. So, rating is less than 3. Again, I'm interpreting this terminal node over here, terminal node, the last link here. So, is rating greater than or equal to 3? No. So if it's not greater than or equal to 3, it's less than 3. And what's the next decision? Age, if I'm going this side, remember to the left is a yes, and age is greater than or equal to 50, then we're at the terminal node right over here. Then we predict you are what? A 0. Not a cheater. And that's about it. That's how you interpret this. And again, to reach this decision, there are 0 people that rate their marriage less than 3 and are age greater than equal to 50. There are 0% of them are cheaters. And this used 2% of the data. And that's how you interpret, again, a decision tree. Now, I'm going to stop this video right now. And part 2, we're going to explore a little bit more information of what decision trees can offer us.